All right, so folks, thank you for joining. I'm here with Billedison from our Top Coder community. He did a fantastic webinar a few weeks ago on Unity development and creating your own Dino game. And we ran out of time. It was such a great webinar, so much great content that we decided to put a pause and have part two. So this is part two of getting started with your own Dino game using Unity. So thank you, Billedison, for doing this, and everybody listen in and enjoy.
Hi, everyone. Welcome to the part two of the Create Your Own Dino Game webinar. So first, let's quickly review what we have done in part one. So this is the game we created on the part one. We make the dino run and we can jump it. And we make the road longer indefinitely, so the dino can run forever. And let's see what the computer game looks like. This is a computer game. So the dino should jump over the obstacles, the cactus. Once it hits the cactus, the game is over. So it's a very simple game. Okay, let's go back to the game we created in the part one. Now, what do we need to do? We are in the part one, we created a layer to hold the ground, and we made the dino, and we move the camera to follow the dino. And now the next step is we need to create a layer to hold the obstacles. So we just create an empty game object and name it like obstacles. Okay, inside the obstacles, we have an obstacle is a cactus. So for the cactus is a sprite, 2D sprite. And in the part one, we already use the sprite editor to split the sprite sheet. This sprite sheet is a single image that contains all the graphics that are used in this game. And we use the slice tool to slice these graphics into individual image. So there's a cactus 1 and cactus 2, etc. Then we can use them now. And let's go back to the cactus. We just name it cactus. And we can drag it here. So this is the cactus we just created. And you know, on the road, there will be many cactus. So the ground if you remember, we just have 4 ground tiles. And we will move the past ground tiles to the next, so that the dino can run it. We will reuse every past ground tile. Also, we don't need to create infinite cactus. We can just create several cactus and reuse them. So we just create one cactus, then use the prefab. We can make many duplicates. So we just create one cactus sprite, and now we need a collider. So we can create a box collider. So you see is a green rectangle around the cactus. So it's a box collider. And now, if we just move it on the road, yeah, just like this. So you see in the game there's a cactus. If we run the game now, what will happen? Yeah, the cactus will block the dyno. Yeah, because we added the box collider. Okay, now we created the cactus and without writing a single line of code. But now it's time to write the code because we need to create multiple cactus. Also, we have a variety types of cactus. So we can change it like this or like this. To change the type, we can use the script. So we create a script called cactus control and open it. Yeah, it's a cactus controller. By default, it creates two event functions. If you don't remember the event functions, we can go back to here. So Unity provides a list of event functions. These four functions we will use frequently is a wake, a start, and then every frame the update function will be invoked. Then once it's dismissed, the onDestroy function will be called. But for the cactus, I don't think we need these event functions. So we can just remove them. What we need to have in the cactus controller, first we need to change the graphics. So we have a list of sprites to change the graphics. And then the cactus has a type. We can just create a property, public property type, get set. Also, we need our sprite renderer to get the size of the sprite. Yeah, why do we need this? You see, we have a box collider, but if we change the sprite here, you see the box collider doesn't change automatically. We have to, on the editor, we have to reset it to make the box collider size match the sprite size. But we will do it by the code. So we need the sprite renderer to get its size. Also, we need the box collider to adjust the box collider size. Then we need an initialize function so that we can initialize the cactus. First, we need to initialize the sprite renderer component. Also, the box collider component. Then we can initialize this type. So each type has a different sprite. Basically, we can just randomly choose a sprite from the array of sprites. Then let's see. Let's set the sprite renderers sprite to the sprites that we randomly choose from the sprite array. The index is type. Then we need to update the box collider size to match the sprite. So we can get the bound size from the sprite renderer. That's all. Now we need to attach the cactus controller script to the cactus sprite game object. You see, for now the sprites are 0, and let's see how many sprites we have. Okay, we have 3. So modify the size to 3 and jack the cactus 1, cactus 2, cactus 3 here. Now let's run again. See what will happen. Okay, try again. Oh yeah, because we are no one calls the initialize. Maybe we just temporarily add the event function back, initialize it. Then you will see each time when you run the game, the characters will be different. Yeah. Okay, so it means our code works. But we will invoke the initialize in other script. So we remove the start event function. We can jack the cactus to the prefab folder, so the cactus becomes a prefab. Then we can replicate it in our world manager. We write a world manager to control the entire gameplay. Now let's go to the world manager. And we need to create the cactus. So we have a cactus prefab. It associates with the cactus controller. We just right here. Also, we need layer for the obstacle. So this is the obstacle layer. And now we can associate the obstacle layer to the world manager. So this is the obstacle layer. And this is the cactus prefab. Oh, sorry. Obstacle layer, cactus prefab. Okay, we associated it in the inspector on the editor. Now we need to create the cactus. Then how should we create a cactus? As we know, the ground tile are reused. So if we just put several cactus on the same ground tile, so once the ground tile are reused, then the cactus are reused as well. So we can write code like this. Then we can define a variable like how many numbers of cactus and maximum we can have on the same ground tile. So by default is 2, and we declared it as a serialized field, so we can adjust the value on the editor. You see, we can adjust the value on editor. Then we can define the total number cactus prefabs we need to create. Then we need another array is how many cactus we have, cactus controllers. We created an array to host it. So we can instantiate the array because we have no how many number of cactus we will have. Then initialize every cactus. Cactus controller. We can use the instantiate function. This is provided by the Unity. Instantiate the prefab. Then we duplicate a prefab. Now we need to add it to the obstacle layer. To add it, we just set the transforms parent to the transform of the obstacle layer. By default, we don't want to see the cactus. So by default, we set is active to false. Then we add it to the array we just created so that we can access to the cactus object later. All right, this is the cactus we just created. Now we need to set the cactus position while we update the ground position. If you remember, the ground position will be updated while the dyno is a new ground tile. Once it's a new ground tile, we will move the previous two ground tile to the next one. So once it hits the new ground tile, we can yield or generate obstacles on the next ground. Then we can get the next ground index first. Because we use the reuse the ground tile, so we need to modular the ground's length to get the next ground. Then we can create a function like yield obstacles on ground. We create this function. Maybe not next index. It should be the ground index. Okay. Now we need to get the ground position, the current ground position, because we need to set the cactus position based on the ground position. Transform our position, we get the current ground position. We just need the x value of the ground position, so ground plus x. Ground position. All right. Yeah, but if we see the ground tile, you see the position is right in the middle of the ground. But what I want to get is the left side point, left right point, leftmost point is position. So we need to get the we need to minus half of the ground width. The half of the ground width is the so minus 0.5 times the ground size of x. So it's a half of the ground width. Because it's float, so we have to use the 0.5 f. Now, how many cactus we have? Or we can make it randomly. We need to use the unit engine random, because if we just use the random, if we just use the random also exists in other namespace. You see the system random, so we need to specify the unit engine random because we want to use random under the unit engine namespace. We will create at least one cactus at most. The max number cactus that we have specified by default is 2. So it will create one cactus or two cactus. Then let's calculate the margin between these cactus. So it should be the ground width divided by the number of cactus plus 1. Then we can, because we will reuse all the cactus, we can calculate the cactus we will use based on the ground index. Now, we can set these cactus we will use to our active mode. Let's remember we set this to the inactive mode by default. Also, because we will reuse these cactus, then by default we will set all the cactus we will use to inactive at first. Now we will see these cactus we will use. That. First, we need to make them active, and then we can initialize it. Then we need to set the position of this cactus. We need to calculate the position of the cactus. Based on the leftmost point of the ground and the margin of between these cactus, as well as index. Also, if we go back to the cactus, you see the original point is also in the middle of the cactus, but we want to set the position of its bottom middle point. Then we need to get the cactus size from its sprite renderer. Controllers. And we can get component sprite renderer. Get size. Then we can set the cactus position. We already calculated is X position. For the Y position, it will be based on the ground position Y. The cactus size half of the cactus height, and the Z position will be the same as the ground position. Okay, then we yelled the cactus on the ground. Now let's go back to the game and see what will happen. Yeah, I think we need to remove it first because now the cactus will be duplicated by the script. Let's make it run. Yeah, you see there are many cactus now. Try again. Oh. Maybe we need to adjust the number of cactus on ground, make it smaller, and try again. Yeah. There are many cactus now, and the cactus type is also different. They are randomly. Okay. Then the next step is once the dyno hits the cactus, the game should be over. Now we need to implement this logic. Go back to the on-client enter 2D. This is the event function. It will be triggered once the dyno hits the collider. So if the client object name starts with cactus, then it hits cactus. The world manager should be game over. Then we go back to the world manager and implement a function on game over. So what's the game over? What will happen? The game should not run. The player should die. Then it should not run. Should not keep running. Then we can implement a function die for the player or dyno. Then animator should play animation, maybe the dyno or dyno die, but I'm not sure if we already created the animation. So let me check. No, we don't create the dyno die animation yet. We just created dyno jump and dyno run. So it's time to create a dyno die. Double click. It will open the animation editor, then select the player. Now we can create a new clip. Name it like dyno die. Then go to the sprite sheet and inject the dyno die image here. Then we created the dyno die animation for the player. Then we can create the dyno die here. Also, we need to make it a stop. So not just make it play the dyno die animation. We also need to freeze the rigid body of the dyno. So set its constraints to freeze all. Then it cannot move at all. Then let's go back to the world manager on game over. Let me see if we have no. So on game over, we need to make the player die, but we didn't have a reference to the player. Then we need a reference to the player. So we need a player controller, player. Then on game over, the player should die. And don't forget to associate the player to the world manager on the game editor or on the Unity editor. All right, let's try again. Yeah, it stops, but the player doesn't play the dyno, play the dyno die animation. Then let's see what happened. The hit name is cactus clone. So you should call the on game over, and you should call the play dyno die. But why it doesn't play the dyno die? We can start debugging. Let's go back to the player and see the animation. Yeah, it has the 3 animation: dyno run, dyno jump, and dyno die is the animator editor. And let's add a log on the player die function. Say is player die. Oh, the dyno die. Yeah. You see, the dyno die should play like this. And let's run again and see what will be output. Here the dyno. Yeah, it called the dyno die. But why it doesn't work? Maybe let's recreate it. If we just call the, oh, I see. Because on the update, we keep it running. So we need another flag called game is over. Because the game is not over, even we call the dyno die and it plays here, but on the next frame, because it's on ground, so the dyno is still called wrong, then it will play the wrong animation again, so we cannot see the dyno die animation. Then we need a flag to tell the game is not running now. We can create a flag that is game running. By default, the game is running, right? By default, the game is running. But once the game is over, the game is not running. And then on the player controller update, if the game is not running, do nothing. And let's try again. We have a compiler error. Oh yeah. Add an extra semicolon. Try. Okay, the compiler should be fixed. Yeah. You see the once the dyno hits the cactus, the game is over. The dyno plays the dyno die animation. Now the next step we need to add the HUD, the heart, so that once the game is over, we can restart the entire game. To control the heart, we need to create a new script, maybe name it to the heart controller. Okay, we create the heart controller. So we need to reopen it because it's a miscellaneous file. Okay. We need to reference the game over image. First, we need to using the Unity UI namespace. Game over. Because the hardware we use the UGUI or Unity UI. And we don't need these two unit functions because the hard controller will be controlled by the world manager based on the game status. So we can update the view of the hard. If the game is running or not, to set the game over image active or not. If the game is running, then it's not active. If the game is not running, then it's active. So like this. Also for the restart button, it should be a button. We add a button component and on click, we need to restart the entire game. But its click function is not written yet. We can write the click function first. So to restart the entire game, it should be the duty of the world manager. Restart game. So how should we restart the entire game? We can restart by the scene manager of the Unity. So scene manager is provided by the scene management namespace. So we need to import the Unity engine scene management. Then we have the scene manager. We just reload the current scene. Scene manager provides us a get active scene name. So if we reload the current scene, everything should be reset. Then let's go back to the restart button. We just drag the world here and select the restart game from the world manager. Now we can adjust the position of the game over and the restart button part. And then let's start. Yeah, you see if we click on the restart button, the dyno will run again. But by default, the game over should be hidden. Then we can control it on the world manager. Control it on the world manager. We need to reference the card. World manager. Then by default, we need to update the view at the very beginning of the game. So we put it in the start event function. Then once the game is over, we need to update the view again. Then let's see. Oh yeah, we forgot to reference the hard controller to the world. First, we need to reference the hard controller to the hard canvas, then reference the game over image here. Then we reference the hard controller to the world manager. Then let's try again. Yeah. Now the game is running, and once the dyno hits the cactus, the game is over, and we can click on the restart button to restart the entire game. All right, so the last thing is we need to know the score. The current score we have. So we just create a text to hold the score. So we can see the score here, and we can make it pin to the right. And adjust the font size, make it bigger, like make the font size to 22. Yeah, so this is the score. By default, the score is 0000. And we can make it larger, like 26. Yeah. And we can make the UI scale to make it scale with the screen size, so that you see if we scale the screen, we see the HUD, the hard, is scale according to the screen size. So this is the score. Now we need to write the code to update the score on the heart controller. We just need to write a function update score, pass the score in, and we need to reference the score text. And once we reference the score text, we just convert the score to the string with the leading 0, 5 digit at most, to score D5 to string pass the parameter D5 and assign it to the score text field. Then on the word manager, we need to update the score. To update the score, we need to calculate the score. So how to calculate the score? The score is based on the distance that the dyno runs. So we can get the score on the player controller. Write a function get score. So it's very simple. We just see the current position of the dyno minus its initial position, but we don't know the initial position yet. So on the start, we can get the initial position. So the initial position is the position of the dyno at the very beginning. Then we get the initial position. And we set it to int because by default is a float. Then we get the score. Then we need to call the get score on the word manager and then update the hard text. We can write it on the update event function of the word manager. First, we need to that if the game is not running, then do nothing. So if the game is running, then we get a score from the player controller, get score, then update the score to the HUD controller. Also on game over, we can do the same. So it's ensure that once the game over, the score is up to date. Now let's play the game again. Yeah, it looks like we forgot to reference something on the inspector. So we need to reference them. Okay. Try again. Yeah, you see the score is updating. Once the game over, we got the 35 score, 35 points for this game. Once the game is restart, everything is reset. All right, I think we are good for now. Because we can only do a very basic version on the webinar due to the limitation of the time. In the full version, we also added like the height score and the background, like this cloud. We don't have time to do this in the webinar, but if you want, I can share the full source code of this Dyno app with you. Thank you, everyone. Any questions?
Thank you very much, Billedison. Thank you, folks, for joining. If you do have any questions, let us know. In the meantime, we will make sure to post this recording up so that you can watch it if you need to get more details. But thanks again, Billedison, for hosting this. This is great. This is such a cool game that everyone can learn to do through you. So thanks, everybody. Have a great rest of your day. Bye-bye.
Thank you. Bye.